Welcome to the Ex Terra Podcast. The Ex Terra mission is to explore and discuss the business of space and its effect on the national and global economy, as well as life on Earth. How does what happens in space affect your life every day? That's what we're exploring on the Ex Terra website, as well as on this podcast. My guest is Moriba Jah, an associate professor of aerospace engineering and engineering mechanics at the University of Texas, who recently joined Apple co-founder Steve Wozniak's startup venture Privateer as chief scientific advisor. Moriba, thank you for joining me.
Hey, thank you very much, Tom. It's a pleasure to be here.
Moriba, you've had an intense and pretty rich career in the space sector over the last 20 years. So tell me how you got interested in space and the problem of space debris.
I know we don't have enough time on the podcast for me to really get into it, but just rest assured, it started off with me being a security guard in the United States Air Force, guarding nuclear missiles at Malmstrom Air Force Base in Montana. And during my night shifts guarding nukes, I used to see dots of light go across the sky that weren't meteors and they weren't planes. Turns out they were satellites. Sometimes they'd disappear in the middle of the sky, which would freak me out. I thought they were UFOs at first. I guess they were UFOs for me. But, once I found out that these things were, human-made stuff orbiting the Earth, it really piqued my intellectual curiosity. So I figured I needed to know more about that. So I just, got a PhD in that sort of thing.
Oh, went off and got a PhD, just toss that aside. Well, there are obviously more and more objects being launched into orbit. I mean, last week, I don't know how many satellites were on the SpaceX launch that occurred, but it seems like there were a lot of all different sizes. So what problems besides collisions are there? For instance, classifying debris types, how to track them, how to mitigate the problems by deorbiting and those kinds of things.
Yeah, I mean, look, I'd say most people are really focused on the collision thing, and maybe even uniquely focused on the collision thing. It seems like there's this eye of Sauron. It's all about collisions, except that that's not the case. For one, we don't really even have a census of this human-made or anthropogenic space object population, meaning we can't measure the whole thing. There's a bunch of stuff that is really untrackable. Millimeter size stuff, things that are like maybe 1 centimeter in size, which can be lethal to satellites. So there's random bullets up there. The smallest stuff that we can track is like the size of the cell phone. And it turns out we don't have a database that tells us the size, the shape, the material properties of all these individual pieces in the population. Every database out there pretty much models all of these things as if they were cannonballs, spheres. And we know that there are very few spheres in space. So we have a problem in getting kind of these demographics of this population to really understand all these physical features, which really makes a big difference when it comes to companies that like Astroscale, they want to clean up space debris and that sort of stuff. They're not in it to rendezvous with cannonballs or remove cannonballs from orbit. That's kind of easy. There's stuff, rocket bodies tumbling at very high rates, massive objects, things that are smaller. We just don't have a comprehensive database on these things. So that's one of the things that we need to change. And then in terms of problems that you were talking about, look, beyond the whole collision stuff, I don't know, there's like ground-based astronomy, which has suffered because of light pollution, light being reflected off of these objects. Just like when I was an airman, guarding nukes and looking at the night sky and seeing these dots of light, astronomers see many more of these. I mean, I was seeing that stuff back in the late 80s, 2022, you have massive quantities of these objects reflecting light towards the ground and corrupting, astronomical science. So there are a variety of problems that we have regarding space traffic and orbital debris that go well beyond just collisions.
But that's only going to get worse. With the Starlink satellite constellation, the OneWeb satellite constellation, the others that are being planned that have literally thousands and thousands of satellites to provide internet service to underserved areas, which is a noble goal, but it's going to really cause a problem with the amount of stuff that's in space.
Yeah, so I would say it this way, Tom. Here we can make at least some analogy to air traffic. I mean, these things are not one to one, but I don't know. Look, 100 years ago, when you looked up at the sky, you didn't really see planes going by. Now, here I'm living in Austin, Texas. Seems like every few minutes, if I try to pay attention, I'm going to see something going across the sky, a plane, right? Sometimes I can see the contrails, that sort of stuff. I think it's going to be similar with our night sky, meaning we're going to see more traffic. At some point, people are going to just naturally start tuning this stuff out because there's some benefits to society that comes from air travel. There's some benefits to society that are coming from satellites, everything from position navigation, timing, climate change, monitoring, that sort of stuff. So I think we just need to make sure that the way in which we launch things and operate things is something that's jointly and holistically managed and isn't to the detriment of the environment, that we're environmentally conscientious as we do these things. So I think that there's a right way to do it.
Now, you mentioned that there's still some research that needs to be done. Can you be a little bit more specific about what you think needs to be researched as far as the orbital debris situation is concerned?
Yeah, so I'll start it this way. People in the community are talking about enforcement of space laws. We need to enforce laws. I'm like, okay, well, how do you enforce something that you're not managing? How do you manage something that you just don't know? And how do you know something unless you measure it? So it all boils down to measuring. And, the United States, we have our own space surveillance network that the Department of Defense manages, but those observations aren't publicly available. We have scientific telescopes like my own at UT Austin, remotely operated stuff. I can make that available. The point is that we have many different sectors across the planet that have eyes on the sky, but we don't combine all the eyes in one bucket to try to figure out and sort out what's going on in orbital space. So I think the biggest hindrance to really understanding the population is a lack of sharing of data, and we need to solve that, and which is one of the reasons why I developed this whole thing called Astrograph, which was meant to be this kind of multi-source, crowdsourced database of stuff in space, is to try to start getting to aggregating all these observations. Once we can do that, then we can each infer different hypotheses and models from those data and then compare notes. Hey, this is what I think, given the data set. Oh, when I evaluate the same data, here's my opinion. Are these things consistent? Are they inconsistent? Why? So we need to engage in like the scientific method from this aggregated data set, but getting the aggregated data set is the biggest hurdle.
Talk a little bit about your research interests at the University of Texas.
Yeah, so even though my background is in astrodynamics, which is the science that studies motion of stuff in space, I've extended that to be very transdisciplinary in the sense of realizing that in order to solve this wicked problem of space traffic and space debris, it takes more than just one disciplinary kind of endeavor, which means that I've gone into a little bit of law and policy, looking at social science and how human behavior is exemplified and manifested in how we operate and launch stuff into orbit, and looking at environmental science, treating near Earth space as an additional ecosystem to land, air, and ocean, saying, hey, we have land, air, and ocean, and we have near Earth orbital space, which is a finite resource because it's not infinitely vast. And the orbital highways that we use are getting saturated in their carrying capacity. And so trying to apply things like a space traffic footprint, like a carbon footprint analog, to stuff in space as well. So yeah, so, and there's something called the Texas Immersive Institute, where we're actually developing a TV show concept called Shifted Space, which we're trying to focus on how do we recruit empathy across humanity and persuade each person to embrace stewardship as if their lives depended on it. So all this stuff is happening at University of Texas at Austin.
Moriba, is space debris a problem to be solved, or is it so complex that it's going to be more of a trade-off between risks and rewards?
Well, I think that's a very interesting question. It really depends on how we define solved. I mean, if we look at plastics in the ocean and we ask that same question, will ocean debris ever be solved? The answer is no, because there's some amount of plastics or microplastics that will forever be in the ocean. Like the ocean will never be in this pristine condition as it was hundreds of years ago, before people really started polluting it, right? So I think it's the same for near Earth orbital space. There's a level of filth in the bathwater that we'll always have to live with in orbital space. But what we can do is we can flatten the curve on the growth of debris. So just like we have COVID and we're trying to flatten the curve on the pandemic, we can very analogously try to flatten the curve on the growth of debris, mostly if people adhere to the science. And the same way that people say, hey, if you mask and social distance, we can flatten the curve. In orbital space, in order to flatten the curve on the debris growth, we need to be compliant with guidelines that scientists and engineers have basically agreed upon the world over. And there's a high degree of non-compliance with those guidelines because most of them are not legally binding. They're just suggestions. So we need governments who have the responsibility in terms of international law, treaties, and conventions to make these guidelines their own national space law. And then, like I said, measure to know to manage, and then manage to enforce. That has to be the path in each country.
Late last year, the Russians destroyed one of their own satellites and caused the International Space Station to have to change its orbit for a brief period of time. What does that do in the realm of space debris when you have not just what's up there naturally from launches and disintegrating satellites and what have you, but when you have a government that's actively destroying its own satellites, creating more orbital debris? How does that all fit into this matrix?
Horrible, man. It's a horrible thing. And people can say, oh, well, maybe it was in an orbit where things will, decay in several years and that sort of stuff. It's the analogy of urinating in your own drinking water. It doesn't make sense. It's pretty horrible. And we need to have some transparency, and we need to see some consequences for this sort of behavior. I think, we have treaties that talk about harmful interference in space. I would say that this constitutes harmful interference to lives aboard the space station, to satellites that we depend upon for certain services and capabilities. This is harmful interference. I mean, logically, in a common sense kind of way. But again, the treaties are very broad in terms of the language and how these things can be interpreted. So I think the world just needs to come together and say, we're not going to tolerate this anymore. And there are going to be some sort of compensation for damage. This sort of activity we can constitute as harmful interference. And, if people have to move out of the way and that sort of stuff, that is a damage. It doesn't have to break anything. The fact that people need to alter their behavior as a consequence of intentionally blowing up something on orbit, that should constitute a damage legally. And there should be some form of compensation to those affected as a consequence of this sort of behavior. That we need to take advantage of this event to do that. And here's the thing, man. I looked at this movie, watched the movie Don't Look Up. It really upset me. Okay. It really upset me because I could project myself into Leonardo DiCaprio's, I think, some professor from Michigan State, right, who discovered this kind of comet. I projected myself into this character and I was very empathetic. I'm like, yeah, I feel in many respects, I go around the globe kind of shaking my fists and trying to raise awareness at this problem. And it doesn't fall in completely deaf ears, but most of the population of the world has no clue that this is an issue. And governments aren't moving in a coordinated way quickly enough, swiftly enough to try to mitigate this whole problem like you just highlighted with the Russian anti-satellite test. So this is where I'm trying to say, look, we really need for people to actually, be action oriented and really, sink their teeth into this problem. But again, compensation for damages and that sort of stuff, I think, is a requirement.
I'm talking with Moriba Jah, an associate professor of aerospace engineering and engineering mechanics at the University of Texas, who recently joined Apple co-founder Steve Wozniak's startup venture Privateer as chief scientific officer here on the Ex Terra Podcast. You can take a moment right now to click on subscribe so you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Moriba, it was recently announced that you did join Privateer as the chief scientific officer, as we talked about a couple of times. What is Privateer and what does it do?
So I would say that Privateer is very much interested in making a positive difference in the 3 S's of space safety, space security, and space sustainability. In order to do that, one of the things that I had brought up is aggregating a data set to then, from this aggregated data set, really extract or abduct hypotheses, models, infer things, and make that knowledge go from data to knowledge in a way that maximizes desired outcomes. I'm going to call that decision intelligence, the ability to take and manipulate data and information in such a way as to maximize desired outcomes. So Privateer really is about developing a decision intelligence platform that can provide bespoke knowledge about stuff regarding the space domain that can aid people be safer, can help in security and sustainability issues.
Now, the company recently stated that they're planning to launch their own satellites for data. Is that kind of almost a contradiction?
Yeah, so that sort of thing has come up before. I think it's not really a contradiction in the sense that number of objects in and of itself isn't the issue. It's number of objects with large uncertainty and people just making decisions without coordinating with other people that tends to be an issue. Just like you have vehicles on the road that monitor traffic. I mean, we have people in, things, let's say automobiles on the roads that monitor traffic. And you have buoys in the ocean collecting science and that sort of stuff. We don't look at the buoys on the ocean as being things that pollute the ocean, or the vehicles looking at traffic monitoring as basically being a detriment to, the traffic hazards and that sort of stuff, even though they're part of that population. So I think whatever on-orbit platforms that Privateer uses, whether it's our own, and being able to do ride shares, putting our sensors on other people's satellites and that sort of stuff, which is also part of the model. I think those things, if done responsibly and adhering to things like the guidelines that I talked about in terms of debris mitigation, and even the World Economic Forum developed this thing called the Space Sustainability Rating to incentivize people to behave in ways that are markedly leading to long-term sustainability of the environment. We're definitely going to do those things. So we're going to put our money where our mouth is, as a matter of speaking, and do things, be responsible, space operators when it comes to that.
Do you feel like older satellites are more of a problem than newer satellites, as many of these newer spacecraft are being designed specifically to deorbit at the end of their useful life?
Well, I'll put it this way, Tom. I've coined the term satellite gerontology. Satellites age, and based on how things were done before, where, look, things that have been up there since the 60s didn't have the benefit of what we know today, right? And so some of these old rocket bodies still have unspent fuel. They're ticking time bombs. They're what I call super spreader events. When that stuff blows up, it's not a matter of if, it's when. It's just going to generate, tens of thousands, hundreds of thousands of pieces of debris. We've seen it happen already. So I'm very worried about the older stuff. But it also means that, because these things weren't designed for demise, which is kind of the phraseology that we use in the community, this design for demise, because they weren't designed for demise, means it's much harder to remove for those people that want to clean these things up. And the structural integrity of these things, because they've been in space, bombarded with radiation, micrometeoroids, maybe even smaller pieces of debris, who knows how brittle this stuff is? Like if you go grab it, is it going to explode when you go grab the thing and that sort of thing? So there's just a lot of science that still needs to be done to try to make this close, actually.
What do you see as far as now the efforts to refuel satellites? We're seeing that being an up and coming technology where basically a flying gas station will go dock with a satellite, refuel it, and extend its useful life. How does that affect the dynamic?
I'm all for minimizing single-use satellites. Just trying to take analogies, right, from sustainability on the planet. We try to minimize single-use plastics. We should also try to minimize single-use satellites. If we can refuel things, if we can service, repurpose, recycle satellites, I think the global community is all the better for it.
What do you think is a greater threat? Are they the large satellites that we can see, or the smaller debris that we can't see, or is there something else that we haven't thought about yet?
I love this question because in the space community, we have camps. There's the camp that says, oh, millimeter-sized debris is the biggest problem, and that's all we care about. Again, the Eye of Sauron is focused on millimeter-sized debris, right? Clearly, that is ridiculous to even make such a statement like that's the only thing that matters. Then there's the other camp that is like, look, there are all these derelict rocket bodies, again, the ticking time bombs. We know that these things, large objects, are going to become things that are much, much smaller. So those are the problem. I would say this. Why do we have to be or people? We tend to be, oh, it's either this is the problem or that's the problem. And let me tell you this, Tom, it's not an or issue, it's an and. The millimeter-sized debris is a problem, and the large derelict rocket bodies that are going to explode is a problem. And there's this other stuff that we don't even know yet, the enigmas, the unknown unknowns, right? So all of these things are problems, and we need to approach this very holistically instead of saying, well, we just need to decide one or the other.
Moriba, we're just about out of time, but I want to ask you to look out over the next 10 to 15 years and tell our audience what you see coming in the field of space commerce.
I believe I'm going to be an optimist here. I believe that common sense and collaboration and coordination, these three C's, you can tell I've been trained by the government at some point, can actually come together and make a positive difference to the space ecosystem that we can jointly manage, holistically manage near Earth space to mitigate the preponderance of debris, to coordinate space traffic patterns and these sorts of things that will enable the peaceful and unhindered use of outer space to humanity. That's what I see happening in 15 years if we can come together and, no kidding, roll up our sleeves and just make this happen as a global community.
Satellites are obviously a big part of space commerce, and this is what we're talking about, is a number of satellites up there. So is there going to need to be more coordination between the satellite builders, the satellite launchers, the satellite users, all of those things that are generating all of this revenue that we're seeing in space commerce, to make sure that everybody thinks space is vast and there's plenty of room up there, but appears there really isn't?
Yeah. Look, Tom, space is another complex system, meaning that causal relationships are nonlinear. Small causes can have huge effects. The interdependencies are not all well known. People tend to be very stovepipe. The launchers are just the launch people. The designers are just the designers. There needs to be basically more cross communication across these different sectors, because there are all these interdependencies that we're not really managing properly. And so I think if we're going to be successful, which, by the way, I don't want to end on this morbid note, but if humanity wants to extend its expiration date as a species, we have to be able to thrive around another sun altogether, because eventually our sun fizzles out. And before then, we have evidence of very large things hitting the Earth and obliterating, causing massive extinction. So we need to start working on how do we become interstellar. I know that Elon is focused on multi-planet. That's not good enough. I'm pushing it even bolder. We need to become interstellar. We can't even get to interstellar if we can't even solve our own near Earth orbit space traffic issues. So this is critical that we all come together and basically have inclusive dialogues and determine these sort of interdependencies across these different sectors.
Moriba, it's been a great conversation, but we are out of time. Thank you so much for taking some time to talk with us on the Ex Terra podcast.
And thank you, my brother.
We've been talking with Moriba Jah, an associate professor of aerospace engineering and engineering mechanics at the University of Texas, who recently joined Apple co-founder Steve Wozniak's startup venture Privateer as chief scientific advisor. That is going to do it for this edition of the Ex Terra podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, and many other popular podcasting platforms. Be sure to click on subscribe so that you don't miss an episode of the podcast or any of our other videos. You can also get daily news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on Twitter at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.